Hello friends, today our topic is black body radiation. In black body radiation we have to discuss few points. Okay, here the first point is perfect emitter, perfect emitter and absorber of radiation is called black body radiation. Perfect emitter and absorber of radiation is called black body radiation. Okay, for example, an object, whatever we are taking an object, it is a body. Okay, whatever light is absorbing by this body, the same, okay, it will emit the radiation. Okay, the perfect emitter and absorber of the radiation is called black body radiation. Okay, actually there is no perfect emitter and absorber. It is an ideal body which act as a perfect emitter and absorber. Okay, which is act as like a perfect emitter and absorber is considered as black body. Okay, that's why it is an ideal body. It is an ideal body which emits and absorbs, which emits and absorbs radiations of all frequencies. Radiations of all frequencies. It is an ideal body which absorbs and emits all types of frequencies. Okay, here the radiation of black body is called black body radiation. The radiation of black body the radiation of black body is called black body radiation, is called black body radiation. Okay, is here a halo sphere coated inside with platinum black. Okay, see here a halo sphere coated inside with platinum black, coated inside with platinum black. Which has a small hole in its wall, can act as a near black body. Okay, here hollow sphere means it is a sphere. Okay, it is a sphere, okay, having small hole and inside which is coated with platinum black. Okay, which is coated with platinum black like this. Okay, this is considered as nearest black body. Okay, see here example, a reddish glow from the the heating element in an electric stove. An electric stove. Okay, and the second example is white light emitted by the hot filament in light bulb. Okay, once again you check the points. Okay, black body radiation is, which is a perfect emitter and absorber of radiation, is called black body radiation. Okay, it is an ideal body which emits and absorbs radiations of all frequencies. Radiations of black body is called black body radiation. A hollow sphere coated inside with platinum black, which has small hole its wall, can act as near black body. Okay, when we observe the examples here, reddish glow from the heating element in electric stove, glass light emitted, white light emitted by the hot filament in normal bulb, light bulb. Okay, when we plot a graph between intensity and radiation. Okay, what is a graph? Is a graph is plotted between intensity of radiation and wavelength. Intensity of radiation and its wavelength. Okay, see, we will observe that graph. See, this is the graph. Okay, this is radiation and this is intensity radiation. This is radiation intensity and this is wavelength of that radiation. Okay, yes, when we can observe these values at different temperatures. Suppose at 2000 degrees Celsius, 2000 Kelvin. Okay, the wavelength here, it is happened like this. Okay, at 3000 Kelvin, at 4000 Kelvin, at 5000 Kelvin. Suppose this we consider as, this is T1, this is T2, this is T3 and this is T4. Here T4 is greater than T3 is greater than T2 is greater than T1. Okay, here we have to check three main points here when we study this graph. From the graph, okay, a black body radiates, okay, a black body produces two continuous spectrum but emits radiations discontinuously. Okay, from the graph, at given temperature, that means temperature we are taking as a constant. Okay, at given temperature, for example, at this temperature, T1 temperature, what happened? The intensity of radiation is slowly increases. Okay, and wavelength also increase. Intensity increases, wavelength increase. When reach maximum intensity, and then decrease the intensity, further wavelength increases. Okay, this is one main point. At given temperature, at given temperature, at given temperature, the intensity of radiation, the intensity of radiation, okay, this is intensity of radiation emitted, intensity of radiation emitted increases with increases wavelength, with increases wavelength. Okay, and reaches maximum value, and reaches maximum value, and then decreases, and then decreases with further increase in wavelength, further increase in wavelength. Okay, see this point we will observe here. Suppose this point at T3, okay, at T3 we can see this is at T3 temperature, this is happened. Okay, yes, intensity increases and wavelength also increase. Okay, it reaches maximum wavelength intensity, maximum intensity, and then decrease its intensity. Okay, further wavelength increases, even the wavelength increases, but the intensity decreases after reaching its maximum value. Okay, next one more important point from the graph. As the temperature increases, as the temperature increases, as the temperature increases, the maximum intensity shifts towards the shorter wavelength, that means shortest wavelength. Shortest wavelength. Okay, see from the graph. Okay, suppose you can see at T1 temperature, at T2, at T3, at T4, temperature is increases here. T4 is greater than T3, T3 is greater than T2, T2 is greater than T1. Okay, see here, when the temperature increases, okay, the maximum intensity, this is maximum intensity at T4, this is maximum intensity at T3, this is maximum intensity at T2, this is maximum intensity at T1. When the temperature increases, the maximum intensity towards shortest wavelength, this is wavelength, okay, you can see here how this is increasing. This is at T1 temperature, this is at T2, this is at T3, this is at T4. Okay, this is T1, T2, T3 and T4 temperature. T4 is greater than T3, T3 is greater than T2, T2 is greater than T1. But what happened? The wavelength, okay, as the temperature increases, the maximum intensity shifted towards shortest wavelength, Okay, this is about black body radiation, and here the main points are this graph. Okay, from the graph these two values we study.